Our topic this week is managing project quality. Essentially, how do we ensure that our project meets the quality expectations of our stakeholders or the standards that we establish for our project? Our learning objectives are to first review the history of quality movement and, and understand how those philosophies, the quality philosophies, can be applied to project management. Then we look at a model that assesses the maturity of an organization capability in running projects. And then we look at the project quality management, and we learn the tools and techniques that are in project quality management and apply those to develop a project quality plan for your class project. Our learning objectives for this chapter are to understand the history of quality movement and how the philosophies that are developed in that movement can be applied to project management. We look at a model that assesses the capability and maturity of an organization in terms of conducting projects. We then look at project quality management and use the techniques and concepts that are introduced in this chapter to develop your class project quality plan. My interest in quality goes back decades when I came to this country in mid-1970s. It was a time that the American industries, especially the automakers, were severely impacted by Japanese imports. You see, back in a number of years before then, in 50s or 60s, Japanese products were viewed as poor quality, very similar to many products that were perceived low quality from China, or at least they used to. Now maybe some of the products that are made in Hong Kong, they're perceived as perhaps lower quality. It was the same situation back in 1950s and 60s. But then Japanese industries embraced the concept of quality, and they improved their products significantly. And that's why the American automakers had a challenge to compete with Japanese cars, especially in the area of their quality in terms of their gas mileage. So there were a lot of unhappiness about that in the country. Some American companies and industries started embracing the quality after seeing what Japanese were able to do with it. And at the time I was working for Chevron, and Chevron embraced the total quality management approach, which was based on Dr. Deming's philosophy. I was fortunate enough to actually attend a seminar that Dr. Deming at the time gave, and I was truly impressed with the thinking and the approach that he was proposing. And so I became very active and very interested in this. I became actually the leader responsible for quality on a major project that Chevron had in Republic of Kazakhstan. It was the Tengiz project. It was a multi-billion-dollar project over a number of years. So I was given that opportunity to lead the quality on that major project. Subsequent to that, I led a couple of benchmarking studies to look at the project management process in Chevron and compare and contrast that our process in Chevron with other major corporations. That's what benchmarking, what those benchmarking studies did. Actually, the effort was quite. It got a lot of attention. It got actually written up in the Financial World magazine. I have a link to that article. You can see young Professor Safai in his earlier part of his career. These benchmarking studies revealed that Chevron's project management processes were not as competitive as other companies, meaning that our facilities were costing us more than our competition. And so this got the attention of the highest levels in Chevron Corporation. And in fact, the vice chairman of Chevron Corporation became the leader to address this issue. And I became obviously involved with the efforts to address the findings and also improve Chevron's capital project management process. You have to keep in mind at the time, Chevron was spending $5 billion every year on capital projects. So this was a significant, so we were able to improve the capital project management process, and we showed over a few years that we were able to save 5% in the projects we did. And of course, when you apply that percentage to the total investment that Chevron was making, obviously that was a huge positive impact for Chevron. Subsequent to that, I actually continued or I became very interested in continuing with benchmarking and joined a company called Independent Project Analysis. And our focus in that company was benchmarking and developing metrics, performance measures for capital projects. And then I extended the practice of the firm to IT projects and developed the benchmarking and metrics appropriate for IT projects. So that part of the business actually grew quite a bit with getting new companies interested in benchmarking their IT projects as well as their capital projects. You have used a Class Angle, and you know that that's a software that my company, Benchmarking Group International, developed that, and I've been interested in being able to really, that came from my interest in having a voice to the customer, a voice that can be heard essentially at all levels of the organization. So the key concepts that I have gathered and I keep focusing on from quality training is to have a focus on customers and have a focus on business. I also recognize the importance of metrics, performance measures, in having those in key process areas. The other very interesting concept is quality movement was this whole concept of continuous improvement, meaning that you always look for ways to improve the processes in an organization. And actually that's yet another learning from this, that you focus on processes. You try to fix the processes when something is not working as well. Generally, people try to do their best job, and when things do not work, when you look into it, typically the cause of the issues are the processes that were used, and therefore it makes sense to make sure that these processes that we use every day in business are looked at and continually improved. Let's take a look at how PMBOK, Project Management Body of Knowledge, defines project quality management. It essentially says that these are the processes and activities that determine the policies that you need to have, objectives and responsibilities for maintaining quality, so that when the project is completed, it will actually satisfy the needs for which the project was undertaken. In other words, we do all of these so that we make sure that the project meets its business objectives and all the quality standards that were established for the project. Sometimes the term quality is mixed or interchanged with luxury, but they're actually quite different. Quality is really to make sure that the product is conforming to the requirements. It is fit for the usage that is designed. Examples would be a safe car, a reliable operating system, etc. On the other hand, luxury or expensive items are bought for status, sometimes for quality, but it's not always for quality. Apple is a good example. That is probably one of the examples that has good quality as well as it's a status symbol. Lamborghini is a very fancy car, typically for status. This particular example shows the car is disabled and being pushed. This actually happened to me. I was in Denver, and with a couple friends, we were going to the mountains for a hike, and there was a huge backup going up in the middle of the week, which was very surprising. But after the backup cleared and we kept moving, we realized that the backup was in fact caused by a Lamborghini that essentially had died or stopped working on the road. So it's obviously embarrassing for the owner of the Lamborghini, after spending all that money, not being to have the basic use of the vehicle, which is be able to drive it dependently. I hope this example differentiates quality versus luxury, meaning that not all luxury items necessarily are of high quality. This is a good chart that shows the evolution of business management concepts over the years and how the corporate management proficiency has improved because of these philosophies, starting with the late 1800s, early 1900s. Frederick Taylor was the one who came up with the idea that there needs to be a focus on workflow and work process. In mid 1900s, the formal discipline of industrial engineering came about, and industrial engineering essentially the focus is to improve operational efficiency, and the role of technology continued to increase, and towards the end of 1900s, early 2000s, there were many technology systems that were rolled out, such as SAP and other enterprise resource management systems that brought standardization in business processes. And beyond that, in more recent years, there has been as you all well know, especially in the field of healthcare, but in many other areas, the idea of data analytics has increased, and it's really prevalent in all aspects of the business right now. Another interesting thing on this chart is forecasting that the future will be mostly focusing on managing and leveraging enterprise risks. So this is something that has not become as rigorous, and the idea here is that risk management, and of course we are now dealing with a major risk of pandemic, risk management is actually a major part of, or it should be a major part of management concepts. The concept of quality has been around for many years. In early ages, quality was mostly equated to craftsmanship in terms of the skills of the craftsman, the way he pays attention to details, the quality of his work, the quality of the materials that he uses in his work. Later on, in early 1900s, Frederick Taylor came up with more scientific approach to management, and in years of 1950s to 2000, there are a number of quality gurus that we will talk about. They include Dr. Edward Deming, Joseph Horan, and Philip Crosby. So we will look at each one of these individuals in the following slides. Frederick Taylor was the first one who came up with the concept of scientific management. Before him, essentially management would set essentially arbitrary rule of thumbs for workers, how much workers should produce every day. Taylor believed that production can be more efficient if it's broken down into smaller tasks, and doing a time motion study of smaller tasks to find out what's the best way and most efficient way of doing those tasks. Many in management ignored the human factor embedded in scientific management, and believed that they could push the profits higher by pressuring the workers to speed up their work. And this dehumanization of the worker is believed to have led to the start of labor unions. Dr. Deming is a statistician by training, and he and Joseph Horan are credited for rebuilding of Japanese industry after World War II and helping them to move from producing poor quality and imitation products to very high quality products in the auto industry, in the chip making industry. There are a number of videos that are linked to this slide if you would like to have a better understanding of how critical their role was in helping Japan and then later on helping the US to also improve the quality of the products that we were making. Dr. Deming embedded his quality philosophy in 14 points for quality in the Out of Crisis book. The 14 points are not individual points, but they really form his whole philosophy and they work together. There is some redundancy among these points, I think more for emphasis of the importance of them. Let's take a look at these points together, and then I also share with you a couple of examples from my experience where I applied these points in real projects. Point one is create constancy of purpose for improvement of products and services. This is to establishing the improvement as a critical element of the overall organizational purpose. And the other point here is the constancy of this purpose. I'm sure you have seen some organizations, some companies that keep changing the direction of the company every quarter, every 6 months, every year, and the point is that there needs to be some constancy of purpose, the general purpose for the organization, and should not be changed constantly. Secondly is adopting a new philosophy of cooperation, a win-win philosophy. This is in contrast with what many organizations look at their relationship with their suppliers and contractors as win-lose, meaning that I need to take advantage, as much advantage as I can, rather than looking at this the relationship as something that we both need to benefit from. Point three, cease dependence on mass inspection to achieve quality. The idea is that you can't really build quality at the end during the inspection of the products. It should be built all along in the product, and making sure that the quality is actually embedded in the product. Point four is end the practice of awarding business on the basis of price tag only. Many organizations, including actually the federal government, many of the contracts were awarded solely on the price or the bid value. That has changed in many organizations, including the government, that now there is more emphasis on the value of a proposal or a contract rather than just the price tag. Number five is improve constantly and forever the system of production, service, and planning. This is the continuous improvement concept, that you're constantly looking for ways to improve the way you're conducting your business. Institute training for especially management skills so that management is aware of their role. And point number 7, adopt and institute leadership for management of people, recognizing their different abilities. This is where is emphasizing the role of management is really to help people, the processes, the technology that is being used to make sure that everything is in place for them to excel and do a better job. Point number 8 is to drive fear out of the organization so people are comfortable with acknowledging mistakes and looking for ways to prevent those mistakes in happening in the future. Also, point number 9, break down barriers between departments. Many organizations have internal competition among their various departments, and the point is that you need to get rid of that so that everybody's working together and you establish a win-win philosophy within the organization as well. Point number 10, it talks about eliminating slogans and targets. This is difficult to understand for many managers, but the idea is to eliminate point 11, eliminate those numerical goals and numbers, and replace them by management, replace them with leadership. Point 12 is remove barrier that rob people of joy in their work. This is really talking about performance evaluation, that it's very common in our organizations, and annual performance, that basically the salary and bonuses are all tied to it. The idea here is that reward system promotes individualism, and it's better to focus more on the team or organizational accomplishment. Number 13, emphasizing again education and self-improvement that is needed for all employees, all workers. And number 14 is put everyone in the organization to work to accomplish this transformation of moving the organization towards continuous improvement philosophy. I also found a video that you have the link of it at the bottom of this slide that also goes through the 14 points, and it has an interview with Dr. Deming, which I find it to be interesting. Now let me share with you a couple of examples of how I applied these points to a building project that I managed in late 1980s. This was a new construction of an office building in Oxnard, California for Chevron operations. And typically for these construction projects in Chevron, we used to award a lump sum contract for a general contractor to build the building per our specifications that we had developed with an architect and engineers. In this contracting approach, all of the risk was passed on or transferred to the contractor by a lump sum contract, meaning that if the project costs more, it was going to be a contractor's responsibility. Because of this contracting arrangement, typically the relationships between the owner, Chevron, and the contractor was very adversarial. So what we decided to do on this project, we awarded a fixed fee plus incentives for the general contractor. What that meant was that the general contractor was given the overall specs for the building, that it was about 120,000 square feet, 3-story building. It had some chemical labs in the building, so it had to handle hazardous waste and the like. So with that general specifications, we asked the general contractors to provide us with bids of what would the fee, their profit and overhead needs to be for managing such a project of this size. So we got the bids, and we selected the successful general contractor, and from there we started working with the general contractor and the architect, and we developed the detailed design packages and got those sent out for bid. And our selection was based on selecting the best subcontractor that can do that particular work, be it electrical, be it mechanical, or sheetrock, who could do that job most effectively, not the least cost necessarily, and based on the general contractor's experience with the local subcontractors, which one of these subcontractors would work with us in a win-win philosophy, so that they don't look at just their work, but they would be considerate of other subcontractors' work, so that everybody basically gets the job done as quickly as possible and would make reasonable profit as part of their engagement in this project. So by doing that, it turned out amazingly successful. It was actually a very much a different environment on the job site, where contractors were working together, the subcontractors were coordinating even among themselves and through the general contractor. So essentially we adopted the 3 points from Dr. Deming in this contracting philosophy to promote the philosophy of win-win. The fact that we didn't want to rely on a lump sum contract and an extensive inspection by the owner at the end. We work with the general contractor and the subcontractors to make sure that the quality and the specifications and standards are met along the way. And this was really our way of looking at the total value for the Chevron, rather than just the general contractor's fee proposal. The general contractor's fee in the grand scheme of the total project cost is not huge amount. So that was not the only thing that we focused on, of how much fee the general contractors are offering us when we selected the general contractor. Rather, we looked at their experience in the local market and their relationship and their reputation with subcontractors. And again, all of those measures resulted in a very cooperative and very enjoyable project to work on. Another example of how I applied these points, Dr. Deming's point, to the same project was to look at the way we managed our safety programs in Chevron for major projects. We typically had certain goals of, say, 100,000 hours without any incident or injuries on the job site. It was very common to have such targets. But when you think about it, those targets really are not meaningful for a case like safety, because no worker comes to a construction site wanting to get injured. Generally, it happens because something is unsafe on the job. So, based on that thought process, we said, how can we make the job site safer by getting workers involved? And what we did, we started a, a program to award a $500 check to whoever from the workers on the job site, to whoever makes the best suggestion to improve the safety on the job site. Now, the first month when we developed this, and I went to the job site, and at the 10 o'clock break, when they're having their coffee and breakfast, I announced the program, and of course there were a lot of eyes being rolled that what does that mean, and is this for real? But we continued with that. The first month we only had maybe 3 suggestions from the job site, even though there were probably about 100 people working on the job site. We only had 3 suggestions. Nonetheless, with the general contractor, with the architect, we went through the suggestions and we selected the best suggestion for the month, and went ahead, and the next month, the same time at 10 o'clock, went and announced that Bob of electrical contractor has made the suggestion, and his suggestion was the best, and here we are, a $500 check from Chevron to Bob. When everybody saw that after the first month, then the suggestions for improvement came in, and by the way, we had an arrangement with the general contractor that as these suggestions came in, they had to be acted on immediately, so that there is no liability for the general contractor or the owner by not fixing the things that are known to be a problem. But having that in place, we were able to identify through the workers on the job site the major issues in safety. Say the 3rd floor barrier on the 3rd floor was down. Somebody would report that, and this would prevent somebody falling from the 3rd floor and getting injured or getting killed. So by implementing this program, we eliminated the artificial goal, really, that we want to have so many hours without accident. We changed that to a program where it cost us, frankly, very little, but we got the people who were most impacted by an unsafe condition on the job site, namely the workers at the job site. We empowered them to be able to impact the safety situation and improve the safety situation by making or by pointing out those shortcomings, and those shortcomings being corrected immediately by the general contractor. Another prominent quality guru is Joseph Horan. He was a Romanian-born engineer who worked for Western Electric in 1920s and 30s, and he published a book, Quality Control Handbook, in 1951. And he was similar to Dr. Deming. He was very instrumental in helping Japan to rebuild its industries after World War II. And his philosophy based on the fact that there is a cost associated with poor quality, and quality doesn't happen by itself. It needs to be planned and controlled. And also he also emphasizes the concept of continuous quality improvement. So now let's take a closer look at Horan's trilogy of quality. These are the three elements of his quality philosophy. The first one on the left is quality planning. This is familiar to us in project management, that this is when we identify the stakeholders, we identify the requirements and the standards that are expected for the product. As an example, in a software development project, we may establish some targets where we expect the number of bugs or problems that we find in the software. And the second part of his philosophy is that we control that. Again, it's very familiar with all the other processes in project management. And the control is basically monitoring the bugs in the example that we just talked about, and monitor how many bugs we find as we do our testing. And there are cases where all of a sudden we see some sporadic spike in the number of bugs, and that's when we really need to take a look at how we can improve the quality. And by doing that, we're going to look at all the processes that are involved that lead into having bugs, and perhaps we can come up with ways that we can improve that process. For example, we may decide that we want to pair up programmers so that they can review each other's work before it gets to the testing stage. And if we do some substantial improvement in the process, then we can actually be able to reduce our acceptable band for the number of bugs that we observe, and we see that the quality, the new zone of quality would be actually far better performance because of that improvement in the process. Horan's approach to quality improvement is laid out in 10 steps, logical steps, starting by building awareness in the organization that there are opportunities to improve, set some goals for improvement, organize to reach those goals, provide training for people who are involved in getting the work done, carrying out those projects to solve problems and make improvements, report progress, give recognition to those who are involved, communicate the results widely, and keep scores, keep track of what has been done, so that motivates people involved with these improvement efforts. And the last point is to keep an ongoing conscious effort, at least on an annual basis, to make sure that systems and processes are reviewed and any improvements potential are taken advantage of. Phil Crosby is also a prominent guru in the field of quality. His background was in US Navy and later on in a company ITT. And he published a book called Quality is Free. And by that he means that the cost of conforming to requirements and meeting those far is far less than the cost of defects when the quality is not built into our product. He based his quality management philosophy on 4 principles. The first one is quality defined as conformance to requirements, very much similar to what we have talked about in the context of projects, that we need to meet the requirements, nothing more, nothing less. And the system that we need to build for quality is prevention, preventing defects to show up in the product in the first place. So that's the concept of our target should be 0 defects. Not that close enough is not does not cut it. We have to strive to reach 0 defects. And the other point is very focused on the cost associated with defects and the measurement of quality. He argues that it should be really the price of non-conformance, not other metrics to try to capture the quality. So cost or the price of non-conformance is what should be the primary metric. Another more recent business management guru or quality guru is Dr. Eliyahu Goldratt, who passed away less than 10 years ago. And his best-selling book is The Goal, which is in its 30th edition. And he has a unique way of communicating the management concepts through stories and novels. Like The Goal is about a factory manager who is struggling with some of the operational issues, and at the same time he's dealing with some personal issues, and it just makes the reading the book a lot easier and more entertaining. In fact, I think The Economist had the comment on the book that many management books are bought by managers and just left on the bookshelf. But The Goal is a book that most managers who buy it, they read it cover to cover. Another book that I would highly recommend for you to read is The Phoenix Project. This is, again, it's a book about IT revolution and especially DevOps. DevOps is a terminology that you may have heard, and it talks about, or the focus is integrating software development and operations, so that everything that is done during the development of the software is having in mind the operational needs of the software. And again, this is a book that is in the form of a novel, and it talks about a factory that has to deliver a major IT project, and or to implement a major IT project, and the difficulties that they have with different organizations working together. At any rate, it is a very entertaining book, and it really brings about the need for all of the various entities in a project to work together, and especially having people who will be responsible for the operations of the project involved during the development and implementation of an IT system. I've read this book, and actually I had purchased it when I was in U.S. courts for all of my direct reports, and also recommended it to a number of my colleagues and peers, and it was generally reviewed very well by whoever had read the book. So now that we have looked at the history of quality, let's look at some of the common threads that run across many of these philosophies. Number one is focusing on the stakeholders, the customer, and what they need, and making sure that they're satisfied. Number two is the concept of building quality into the product, and rely more on prevention and good practices rather than extensive inspection and testing. Number three is when there are problems, look at the processes and try to improve the processes rather than finding the guilty party or who has not done it. Usually the problems arise when the processes are not fine-tuned or appropriate in the organization. Number four is communicating this whole concept that quality is everybody's responsibility. So it's not just the leader of the organization or the project manager who's responsible for quality. Everybody on the project has to feel responsible for the quality of the product that they will eventually deliver. And the last one is fact-based management, meaning that you have to rely on metrics and measurements to know what the problems are, and these are the core concepts that it behooves us to keep in mind as we manage projects. Many of these concepts, of course, came from manufacturing, but over the years they have moved into the area of project management, and specifically IT project management. The capability maturity model was originally developed by Carnegie Mellon University in 1986, and the intention was to assess the processes and procedures in an organization around software development. They developed this in cooperation with Mitre Corporation and Watts Humphrey organization. This model, the CMM model, was later on evolved to CMMI, and that's the integration was added to it, and it became more focused on the overall project, IT project management, rather than just software development. CMMI uses a certain terminology. Let's look at them. Process is defined as the way we produce project deliverables, the activities that we go through, the methods, the tools that we use to deliver or to put in place project deliverables, such as project plan, design documents, and the like. Process capability is what one would expect would be the result of a process. On the other hand, process performance is what the process is actually producing. And lastly, process maturity is referred to as how each process is explicitly and consistently defined in the organization, and how it's managed and measured and controlled. The idea is that how consistently this project is used across the organization. CMMI has 5 maturity levels, which indicate how consistently processes are used across the organization. Level 1 is the initial level, which is basically processes are not in place, processes are unpredictable, they are not controlled, and everything is reactive. This is an organization that's basically very chaotic, and things are not consistent at all. Level 2 is managed, where processes are used by projects, but in a more reactive way rather than being planned and being applied consistently. Level 3 is when processes are identified and established in the organization and used across the organization. And it's a proactive use of these of the processes. Level 4 is quantitatively managed or managed level, which is when processes and the results of the processes are measured and controlled, and processes are adjusted accordingly. And level 5 is optimizing level. This is where the processes are actually continually reviewed and improved in the organization. So level 1, we said that it's an initial level, and this is where an organization is immature in terms of their processes. The processes are ad hoc. Sometimes they're used, sometimes they're not used. They're often used in a reactive mode when problems arise. So this is not provide a stable environment for projects, and projects would succeed in this type of organization primarily by the skills of individuals involved in the project rather than the processes that exist in the organization. So in this case, we essentially have no systematic processes in place for projects to use. Level 2 is the repeatable level. This is when the organization has put in place the basic policies and processes and control measures for managing a project. Typically, these process areas include configuration management, quality assurance, subcontract management, project tracking and oversight, project planning, and requirement management. These are kind of very basic set of processes that need to be in place in the organization to reach level 2 or repeatable level. Level 3 is the defined level. This is when all the processes are documented, they are standardized throughout the organization, and all the projects use those processes as just a normal part of the project. These processes include peer review, intergroup coordination, software product engineering, integrated software management, training programs, organization, process definition, and organization process focus. I should point out that CMMI is used by the federal government still extensively for qualifying the contractors or consultants who are involved with software development or project management in general. And the minimum requirement in many of the requests for proposals is the minimum of CMMI level 3 for companies to be able to even provide a bid. That's the qualification to even enter a bid. Level 4 is the managed level. This is where we have performance measures and metrics established for all the processes, so that the results can be quantified and the results can be predicted. Some of the key process areas that need to be in place to reach this level is quality management and quantitative process management. You see that quality management is actually a fairly high threshold in CMMI when you establish that quality management approach, that you're continually looking for measurements, and ultimately, as we see in level 5, you actually improve the processes. So level 5 optimizing level is the highest level of maturity, where the entire organization is focused on continually improving the processes that are in place. Some of the key process areas that need to be in place to achieve this level is process change management, technology change management, and defect prevention. This is a nice chart summarizing what we have talked about, showing all the different levels and describing what is happening at each level, and what processes need to be used or to be in the organization for it to be able to achieve that level of maturity. So project quality management is the way we improve the maturity in the organization, and as you saw in a couple slides before, actually having a project quality management in place is a requirement to reach CMMI level 4. So what does this entail? If you look at the chart, we start with quality management planning on the upper right, and this is where we decide the quality standards and the processes and metrics that need to be in place to meet those standards. The standards initially may be a few of processes that all projects need to use, but over time these standards can increase and keep moving the organization higher in terms of the maturity. If you recall, when I shared with you the process that we rolled out in US courts, it was intended for just standardizing a few processes in all projects, so that there is some consistency in the organization, and over time the plan was to add new processes and increase the maturity of the organization. The second part of quality management is quality assurance, to make sure and verify that the processes and tools that you have established, they're actually being used. And the third step is quality control. It's basically analyzing the data is collected and see if there are any issues in the processes that we have established in the organization. For example, if we find out that consistently projects are missing the scope, or there is disagreement in the scope of the projects, perhaps we need to re-examine the scope management process that we have established for the projects. And lastly, we make sure that we collect the best practices and lessons learned from all the projects and implement them as part of continuous improvement, so that we are continually improving our project management processes. So in the first part of project quality management, we need to establish quality standards or metrics. And these standards or metrics can apply to project processes, but also project deliverables. So we can have certain standards. In fact, we did make a standard for having a business case for all projects in US course, or you may require that all projects have their project plan laid out and establish some standards that you would expect in terms of the details that are provided in the project plans. It also can focus on project processes, like how do you go about scope management, how projects need to conduct risk management, how do they go about requirements analysis, and so forth. So these are the standards we establish for whatever process or deliverable that we require all projects to have. Standards are agreed upon specifications and criteria to ensure all deliverables meet certain, they meet their intended purpose. And as such, standards can apply to, can be project oriented or can be product oriented. In terms of a product oriented set of standards, we can come up the requirements for reliability or performance of a system that we are putting in place, or the expected response time. In terms of projects, similar things can apply to project deliverables, such as the schedule, cost. We want those to be accurate. We need to have plans for corrections if there are issues associated with those aspects of the project. And as we have talked about, metrics that are basically measurements of quality, they can be applied to project, process, or the product, are an important element of project quality management. The second element of project quality management is quality assurance. This is where we verify that the processes or deliverables are meeting the standards. And this can be done through a number of ways. It can be a technical review, oftentimes referred to as walkthroughs, where somebody would walk you through, say, a design of a product, and the peers can comment on that design. Business review is typically done with the customers and the users of the product, and to make sure that all the product related standards are met and all the deliverables meet the required standards. Management reviews typically focus more on the project in terms of its deliverables and its timeline, and making sure that a project is meeting its intended set of objectives. The third element of project quality management is quality control. Quality control, typically referred to as QC, you hear that a lot. And it's essentially validation and making sure that the product and systems that we put in place, they actually function as they were intended. And they offer all the capabilities and features that was defined by our stakeholders. There are a number of quality tools that are pretty effective in helping us to establish quality and manage processes. The first one is control charts, sometimes referred to as Schuhart's chart. Second one is Ishikawa diagram, or cause and effect diagram, sometimes it's called, or fishbone diagram. Pareto chart is used for prioritization. Checklists, they're put in place to ensure consistency. Flow charts, process maps, these are tools to better understand processes, and especially if we are redesigning processes, establishing what the process is in terms of a flow chart and how it should be in the future. That's a very effective tool. Statistical analysis is really fundamental to the quality concept. As you notice, most of the gurus were statisticians or had deep understanding of statistical processes, because the fact is that these statistical processes or analysis help us understand the variance that we see in the outcomes of various processes, and not to be overly shocked by the fact that there are in fact some variances in what each process produces. This is an example of control charts or Schuhart's charts. The one on the left shows the process outcome. Let's say that in this example we are looking at the number of bugs in 1 man month or 1 person month of software development. So we are monitoring the number of bugs, and on the left side we see that the number of bugs are within the upper limit, the control limit that we have on the upper end of the graph. On the right chart, this is a process that is essentially out of control. As you can see, the number of errors have surpassed what we envision to be the upper control limit for number of bugs. Ishikawa diagram, also known as fishbone diagram or cause and effect diagram. This is when we have a problem and we are trying to find the root causes to that problem. And to do that, we basically think about a number of categories or areas that may have that the elements that contribute to this problem may fall under. In this particular example, we are looking at a problem that requirements are not properly defined. So that's a problem that we consistently observe on a number of projects, let's say. And we are trying to find out why is that the case. Are there issues with in the area of people who are doing the requirements? Maybe they require the training. Maybe the roles and responsibilities among the people are not well defined. Or it could be in the area of methods and approaches, like maybe the documentation that they put together for requirements are not well put together, they're not complete. And we can go on to different areas: management, technology, measurements, and environment. These are the categories that we put on Ishikawa diagram to really stimulate brainstorming and identifying root causes to a particular problem. Another tool is Pareto chart. This is to set some priority for what we need to act on. In this example, we are capturing the number of calls to the help desk, and we categorize these calls of what was the reason that the user was calling the help desk. And in this example, we can see that 82 of them, of the calls, were related to documentation. So the documentation was not clear, so they had to call the help desk to understand how they could do certain things, or maybe it wasn't easy to find. Maybe it's documented, but not easy to find. We see that there are 67 of these calls were related to hardware problems, and 34 were related to software errors, and 10 that fall into others. So in this particular case, we definitely want to address the top 2 or 3 areas. For example, when this we may decide to review all the documentation and really reorganize it, reformat it, or augment it so that it eliminates the needs, the questions that come about of how to do certain things. Maybe we make the documentation more interactive. Maybe we make the documentation more embedded in the application so that people don't have to go to different places to find the information. The second problem, we see that our users are experiencing hardware problems. This could be to a number of reasons. Maybe we need to update the hardware that we are providing to our users. Maybe there are unreliable hardware that we have rolled out and we have to replace that. So this is just an example of how Pareto chart helps us to focus on the problems that are most important. Some of the other quality tools out there, checklist, helps us to make sure that certain items, certain steps are followed. This brings consistency in terms of how people do certain tasks. Flowcharts, process maps, this is to document what happens in a given process, what steps people go through. You would be surprised that many organizations don't have really a good understanding of many of the processes that are going on in the organization. And if they went through the exercise of developing the flowchart for those processes, they may find out that the process is convoluted. Maybe there are steps that can be eliminated. Maybe there are opportunities to streamline the process. Statistical analysis, again, hopefully you have had many training on statistical analysis, and it's an effective tool for finding out the attributes, for example, of an outcome, and knowing that, for example, if something falls out of certain range, there's only really 5% chance in being in that area, so it's a very unusual occurrence. So last element of project quality management is continuous improvement. This is the step that we are looking at the outcome of the processes that we have in the organization, the outcome of the projects, and Making sure that we identify areas for incremental improvements. In many cases, for continuous improvement to happen, we also use knowledge management to make sure that some of the best practices are documented and communicated with all projects. At the end of the day, really, the project quality management plan should support the organization in building better products and better systems. One of the common key objective of all of these quality philosophies is to minimize rework. This point is really can be illustrated in the context of project very nicely. For example, if you have a project and you find a problem in terms of defining requirements, well, that would be fairly minimal rework to get that requirement captured correctly and have that fixed. But if we find a problem during implementation, that could put us or send us back to reviewing the requirement and maybe modifying that and do the redesign and redevelop and test. And clearly the amount of rework associated with a problem later on is far more. So the planning and doing everything up front is really pays off in terms of minimizing rework. And again, the focus and the inspiration should be achieving zero defects for whatever project or product we are developing. That concludes my lecture on quality, and thanks for your attention.